Hello! Today we are going to be multiplying fractions. This is just like what we did in our activity on Friday where we modeled, but today we're going to talk about more specifically the standard algorithm, which a lot of kids really enjoy using the standard algorithm. It's probably their favorite thing to do with fractions because once you learn the process, it's pretty simple, as long as you know your easy, simple multiplication tables. Our essential question for today is, how can an area model demonstrate modeling fractions? This is from the Big Ideas math book, pages 56 through 58, and it is going on page 26 of your interactive notebook. The first thing we are going to do is we are going to look at some terminology, and that is for multiplying fractions. The way that we need to remember this is when we multiply fractions, we multiply the numerators and the denominators and then simplify if possible. So when we're doing this, remember that our numerators are on top and our denominators are on bottom. And I'm going to circle that because it's an important phrase. Now, if you need to go back or pause the video so that you can get this stuff written down, these important little notes, you can do that. There is an example problem. It gives you 3/7 times 1/2, and you'll see how we rewrote 3 times 1 over 7 times 2, and then we answered it. So our first practice problem we are going to solve using the standard algorithm. And with the standard algorithm, the steps that we need to remember are: 1, we multiply the numerators, the top numbers, and then 2, we multiply the denominators, and then if we can, we simplify and we make that fraction in the smallest form we can. Pull out factors and make it a simplified fraction. So for an example for this one, I'm going to write find 1/5 times 1/3. A very simple fraction. I'm going to box it because it's our question. And what we're going to do, I'm going to slow this down a little bit, is we are going to, like I said, multiply the numerators. So we're going to do 1 times 1, the numerator times the numerator. And 1 times 1 is going to equal 1 over, multiply the denominators, 5 times 3. 5 times 3 is 15. And you'll notice that we have a 1 here and we have a prime number. There's no way we could simplify that anymore. So this is your final answer. So that's simple multiplying fractions with standard algorithm. Now the next time we're going to do it, we're going to change it up a little bit, and we're going to get a set of fractions that's a little bit more complicated, a little bit more difficult. And with this, we're going to show you a process where we pull out the common factor in order to simplify prior to solving. So this is multiplying with common denominators. Oh, and oh my goodness, I said the wrong word. I meant to say common factors. I'm going to get rid of that. Fix it. I apologize for that. I was thinking fractions, and I automatically, in my mind, always goes to common denominators, and it's actually not what I'm pulling out. I'm multiplying with common factors, because what we're going to pull out is the factor that can go into both, and I'm going to show you what that means. So our practice problem here is find the answer to 8/9 times 3/4. Now, for the sake of just having something to work with, I'm going to start off by actually using the standard algorithm. You don't have to do the standard algorithm and pull out the common factors. I'm just going to do it because I want to show you how you'll get the same answer. If I were to go multiply straight across, I would do 8 times 3, and I would get what, class? What's 8 times 3? 24. Very good. So if I did 8 times 3, it would equal 24 over 9 times 4, which is what, class?
36.
36. Perfect. But that's not a simplified fraction, so I have to find a factor that can go both into 24 and 36. Can someone with a raised hand tell me what is a factor that can go into both? And I would like you to find the greatest common factor that can go into both. David?
12.
12. Perfect. So let's divide the numerator and the denominator by 12, because whatever you do to the top, you got to do the bottom. And 24 divided by 12 is what, class?
2.
Good. And what is 36 divided by 12, class?
3.
And there is your simplified fraction. Not too complicated, but I'm going to show you there's a way for us to simplify prior to doing the multiplication. And that process is that you are going to first divide out common factors by looking across. You're probably thinking to yourself, well, what does that mean, Miss Engel? So let me show you. I've got 8/9 times 3/4. Now you'll notice I have, and I'm going to blow this up so it's really easy to see. Don't worry, I'll go back to the regular size screen, but I want to show you something. So on this problem, I'm going to look across in a diagonal. So I'm going to look only at these two numbers, the 9 and the 3. And looking at the 9 and the 3, is there a factor that can go both into 9 and 3? Julia? 3. Awesome. So what I'm going to do is I'm going to cross off this 3 and I'm going to say 3 divided by 3 is 1 and 9 divided by 3 is 3. Now what about if I go the other way? I've got an 8 and a 4. Let me see if I can cover that way. You can still see it. What is a factor that can go into both of those, Jonah?
2.
2 can. But I have a feeling that's going to cause me to simplify more. So can you give me a bigger factor, Jonah?
4.
Right. So, Jonah, help me out with this. What's 8 divided by 4?
2.
Good. And what is 4 divided by 4?
1.
Awesome. So now what I'm really looking at is 2/3 times 1 over 1. And so let's multiply those straight across. Now, what is 2 times 1, class?
2.
And 3 times 1?
3.
So notice I got the same answer as I did when I did the standard algorithm. I just didn't have to do the simplifying right there. I just did it in the problem. So the second step on this is you just multiply across. Now, and if you can do this, it actually does save you a lot of time, especially if you find the greatest common factor of both and you really get that factor pulled out. It does help you. So what I'm going to do now, because of space, I really don't think I have enough room to do the next section there. So I'm actually going to go over to page 25 to write the next part. And our next thing that we're going to do is going to be multiplying with mixed numbers. So I'm going to go back to my page 25. So this is 25. And at the top, I'm going to write step 3, multiplying with mixed numbers. So same process, but before we can start multiplying straight across, we have to start off by converting those mixed numbers, that number that has a fraction and a whole number, we have to convert it to an improper fraction. So let's do an example problem. So we're going to do find 1 4/5 times 3 2/3. So the first step, convert mixed numbers. To improper fractions. Does anybody think they can tell us what is the process that we do to convert? Maddie?
First we do 5 times 1, which is 5, and then we add 4.
Good. So what I hear you saying is that we take the whole number, we multiply it by the denominator, and then add the numerator. And then what is our new denominator?
9 fifths.
Yeah, so our numerator would be the 9 that we got, but then we would keep our denominator the same. Good. So this one would be 9/5 times, let's do this as a class. So 3 times 3 is what, class?
9.
Plus 2?
11.
11. What is our numerator? Our denominator?
3.
3, yeah, we keep it the same. So now, we multiply across. And I'm going to see, just because we just practiced it, if there are any factors we can pull out of this. So does somebody see a factor that I can pull out? Raise your hand if you can think of one. David?
9 and 3.
9 and 3. Right, because 5 and 11, those are prime. They don't go into each other. But 9 and 3, we can. So what do I pull out, David?
Out of the 3.
3. So 3 divided by 3 is 1. 9 divided by 3 is 3. Okay, now we're going to multiply across. 3 times 11 is what, class? 33. 5 times 1 is 5. And this leaves us to, we now need to convert back to a mixed number. Yeah, Maddie, can you help us with that? What do I do?
Well, 5 times 33 6 times,
Uh-huh.
which entails that 3 left over, so it would be 6 and 3/5.
Very good. So what Maddie said to us was, we ask ourselves, how many times can the denominator go into the numerator? In this case, 5 can evenly go into 33 6 times. So that becomes our whole number. Then we look at what our remainder is. So in this case, 33 minus 30, our remainder is 3. That becomes our new numerator, and our denominator, once again, stays the same. And that is your answer. The last process that we're going to do today is we are going to go back to what we did on Friday, and we're going to do a real world problem. And this real world problem is going to be using modeling. We're going to make an area model. And if you could, please write down this word problem for me. Problem is, you have 2/3 of a bag of flour. You can make, you can make cookies with 3/4 of the bag. How much of the entire bag do you use? Now remember, when we're doing word problems, we always want to go and circle our numbers and underline the words that go with them. So 2/3, bag of flour, 3/4 of the bag, and then I like to go through and box my question. So how much of the entire bag did you use? So I know I got to answer that question that's in the box before I'm done. And in this case, I'm going to do a multiplication problem. I'm going to figure 2/3 of 3/4, or I apologize, I said that wrong. It's 3/4 of 2/3. The mathematic part of it is actually going to be the same because we can flip our multiplication problems, but it is 3/4 of 2/3. So I'm going to write my problem. Now, I'm going to start off by doing the standard algorithm, just so I can confirm that I got it right when I use the modeling. So, is there a factor or two that I can pull out of this problem, Alex?
4.
Good. What factor do I pull out?
2 you could do divided by 2 is 1.
2 divided by 2 is 1?
And 4 divided by 2 is 2.
4 divided by 2 is 2. Is there another one that we can do?
Yes.
In the very back. 3 and 3. What did you get for that? Perfect. Good job. Okay, so let's multiply now across. 1 times 1 is 1. 1 times 2 is 2. So we used a half of the bag. Okay? Now we're going to use, this is the standard algorithm. The next process is we're going to do the model. So to do the model, I'm going to create myself an area model, which is a rectangle. I just created a rectangle. And I'm going to take the first fraction, which in this case is my 2/3, and I'm going to do represent that fraction horizontally. So I'm going to write over here 2/3, and I'm going to divide my rectangle into 3 sections horizontally. I'm going to try to do this as evenly as I can. 2, 3. And with one color highlighter, I'm going to demonstrate what 2/3 is, which is 2 of these 3 sections. So now I've shown that that is 2/3 of the rectangle. So the next thing I'm going to do is now I'm going to do the vertical part of this, and I'm going to do my 3/4, and I'm going to do it vertically, so I'm going to divide it the other way into 4 sections. Whatever your denominator is, that tells you how many sections you have to divide by. I like doing 4s because I just divide the rectangle in half and then go in half and in half again. And I'm going to color this one another color so that it's easy for me to see. So I'm going to take pink, and I'm going to color 3/4 in pink, going all the way to the top and bottom. And so now I've shown that 3/4 of this rectangle is pink. Now, how do I read this model? Well, what I'm going to do is I'm going to start off by counting the total spaces. Maddie, how many spaces are there? Total?
12.
12, thank you. That is going to become your denominator. Okay? So I just went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then you're going to count the spaces colored with both colors. Alex, how many did you get?
I got 9.
I just wrote that wrong. You got 9?
Yeah.
Are you sure? Maybe you should try counting that again.
11.
So notice here, in mine, there are these orange ones. They're colored both with pink and with yellow, and they turned orange. How many were in that spot, Alex, again? 6. Good. And this is going to become your numerator. And then the last thing you want to do is simplify if you can. So this. So in our case here, we got 6 over 12, which 6 divided by 6 is 1, 12 divided by 6 is 2, and you'll notice we got the same answer as our standard algorithm, which tells us we did it the right way. So, as far as I'm concerned, unless I ask you to model, or unless I ask you to use the standard algorithm, you can do either. It's really up to you how you want. There are other models that you can use. You can do a number line, a tape diagram. There's different ones. This is just one particular example that I think is a pretty easy one to read. But like I said, you have some flexibility, and unless I specifically ask for one versus another, you can use whichever one works best for your brain. Remember, you can always go back and review the video again. You can email me or come see me if you have questions. Otherwise, thanks so much. Enjoy your multiplying fractions and have a great day.